So what you just saw might remind you of a movie or a video game or something. But it's real, almost real, it's possible, according to Einstein anyway. So Einstein came up with the most famous equation on Earth, E equals mc squared. But that's not what we're looking at. Today what we're looking at is something that we call the theory of relativity. So Einstein says that there's two important things that we need to know. One, depending on where you are, things can look like they're moving differently. So you could be driving down the highway and look out the window and see trees going by you very quickly, but going behind you. Or you could be standing next to the trees, and you would say that the car is moving very quickly in front of you. Second thing is that light moves at the same speed no matter where you are in space. So you could be standing on the moon, or you could be moving very quickly in jet or something. And if you shoot a laser both of those places and we measure the laser speed, it will be the exact same. With this in mind, let's go back to our example. Let's say that Monique and her children have the same clock. Not like this clock or like this clock. Maybe one like this. So the way that this clock works is that we shoot a laser from the top to the bottom and back to the top, and we measure how long that takes, and then we can determine the time. So if we send Monique off, her clock might look a little bit like this. So notice that the clocks are still in sync, but Monique's light from her clock has to travel just a little bit further. So if we plug the constant speed with an increased distance, that means we have to have an increased time. And so what that means is that the faster you move, the slower time is relative to someone else who isn't moving. And that's what we know as time dilation.